Hello, everyone. It's Steve with Aptera Owners Club. Okay, so I just got back from a trip, and this live webinar that Aptera did happened to be on the first day of my trip. So I just got back and just had a chance to go over it. A lot of good stuff in here. Um, and I'm not going to go through the entire thing minute by minute, but just wanted to hit some highlights. I'm sure most of you guys have watched the entire thing. So let's just go over and hit the highlights of the thing. All right, so this is what they started with, where we are today. So there's about 42,000 pre-orders, which represents about $1.5 billion. That's assuming a 100% conversion rate, which is obviously optimistic. I don't know what the conversion rate will be. I believe the conversion rate for the Model 3 pre-orders was about 30-40%. So if you suspect that Aptera is going to have a 30-40% conversion rate, you're looking at probably 500 million to 700 million dollars in potential revenue, and that's still very good. And they've raised over $90 million from over 16,000 investors, so that's mostly crowdfunding. It is one of the most successful crowdfunding campaigns in history, with good reason, because I think there is a lot of support in the community for it. And then they talk about the California Energy Commission, and they did say they got the first check back from them. So they've been reimbursed for some of their purchases already. So at the time of the webinar, they got their first actual check back from this grant. So that's good news. And they're trying to do minimal environmental impact. Great. And they talk about their IP, and the two that have been awarded are mostly design patents, but they have many patents pending. Most of their IP, I believe, is probably related to their solar encapsulation tech, and probably some of the way that they're doing their body. But there's a lot of IP happening. Okay, so then let's kind of skip through here, and we'll get to, I think, around 14 they start talking about the cool stuff. Okay, so let's
To
talk
do
about
it.
this.
Interesting note, almost a lot of the factories we saw in Italy have not only glass.
Okay, so he just talking about how there's natural light in the factories in Italy, which is great. But you see that this is a die, and the difference between a die and a mold is something like you inject a liquid into. So plastics are molded generally because you like inject liquid plastic into a mold. A die is something that you just press the material into. So these are technically dies, and these are rough cut, and this is obviously the hood. All right, so let's kind of go through, and they're talking about more of these things.
Pieces, there's a main body part, and then there's maybe 2 or 3 other parts that are also captured in the same die, just so we minimize the number.
So that's something that we kind of figured was the case, is that they were doing multiple parts in one die, and Steve is confirming that this is actually the like the door hinge part, and there's two of them in this one die. Okay, so let's kind of skip ahead here.
So that's all made in the
So
part.
here's
When
the
the part
doors,
comes out,
obviously. It's very
again,
obviously
there's
the
very
doors.
little work that has to happen to it. We're ready to bolt stuff to it, fasten things to it. They're not just regular decorative inserts, they're actually structural, and so the size of them, the method of how they're made, and the shear and tension force that they can withstand are all things calculated by CPC. Part of their IP is how do they put those sometimes very high structural hard points into the tool, into the part when they're making it with the tool.
And these are both B-side tools, so that's the back side of the part. And I think I saw a video by Steve at Aptera Owners Club, shout out.
Hey.
That the little texture patterns on there, the little cross hatching, is actually where the adhesive goes,
That's right.
the bonding agent to stick the two parts together. So you have to do less surface treatment on the other side. You basically pop the part out of the mold, and then you can put the glue on and slap the matching part to it.
We say adhesive.
Adhesive, yeah.
This is a favorite one.
Yeah, this was great, and you saw the video of us standing between these two, so we thought it was amazing that CPC kind of set these up, and you could really envision yourself sitting inside the Aptera, inside these two giant 8,000-pound each molds. You can imagine, they were 20,000 pounds when they started, and they hogged out, more than half the metal. But these are just amazing to see. I mean, we called it heavy metal porn when we were there because everything's so shiny and bright, and you know, it's just an amazing feeling to like be able to sit inside these two massive molds and say, oh, that's the body left, that's the body right. You know, this is the production Aptera tooling.
Yeah, and these are at the final stage of polish, so they're actually ready to go to the next phase, which is they have to put fittings on all of the threaded holes that you see there and install the temperature sensors. There's also some guides on the side, so there's the 4 posts that form the main guide, but
Yeah, so as you can tell, the previous were like rough cut, and I guess they get CNC'd with like a rough cut thing that cuts really fast, and then this is the more polished. These are completely polished, and the only things that are left to do is put some fittings and sensors in this thing. And these are these holes right here are the huge guides that they press the A and B sides, the male and female parts, together. And there's some rods and stuff that they use to like push the thing out once they're done. And then they mentioned that this is part of the A pillar. So it's the body side panel and the A pillar in this thing.
there's some guides that you'll see maybe in some of the other pictures that are sort of bolted on the side that help just sort of pre-align the top and bottom as they come in together. You see pockets for them there. So they do all that there, and then they'll commission it with the small press before it actually pulls out a big part. So, and that happens pretty soon.
Yep. Yeah, in this summer, we'll be seeing the first parts out of these molds.
All right, that is great. So this summer, we are going to see the first part. So that's just, 2, 3 months away. And it's really cool to see all these giant parts. Like, Chris mentioned that this thing was 20,000 pounds, and now it's down to 8,000. So it's 20,000 pounds of stainless steel that they milled, um, and uh, and now it's 8,000 pounds. And now we've seen multiple parts. We've seen the pockets of the hinges, the hood, the doors. I mean, they're making all of them simultaneously. And so, it's very obvious Aptera is serious about production. They're using capital to make production things. This is not some kind of ploy to like get money out of. They really want to build this thing, and they're making concrete steps to it. And here it is, in the flesh, so to say. And it's yeah. We've seen in this webinar they showed us more parts than we've ever seen before.
It is worth noting on these molds, you see kind of the body side part on the left and right at the bottom, but there's another part nested into this mold. So this die actually produces 2 parts per press, and you saw that on the doors too. We actually do 2 doors in 1 press. So this gets us kind of the A-pillar covers and the body side, which is really cool to be able to do 2 parts in one go. And it just saves, press time and gets us parts out quicker.
And just so everyone is clear, I mean, with these dies right here, they can operate at least or even higher than our planned capacity, right? 20,000 vehicles a year, 10,000 vehicles per shift. So they are exactly what we need, not only to get through all of the accelerator orders, but to the order backlog as well, and then to keep functioning for years beyond that.
Yeah, these tools are all designed to produce more than 100,000 parts. Some of the tools along the way, they'll need some servicing, they'll need some repolishing. Things kind of happen to the molds over time, but there's no reason that we couldn't, have our first million Aptera on the road in the next decade with these tools that you're seeing right here. And
All right, so it's very clear why they went with CPC. The honeycomb composite, they just would never be able to scale that up to 20,000 vehicles a year. It's just way too labor intensive. And these things will produce 100,000 vehicles before they need to be serviced. And then if after they get serviced, you can just put them back in service. And Chris is saying that these dies are good for like about 1 million vehicles. So it's a huge investment to buy, all this metal and to mill it and spend the time. I mean, this must be extremely expensive, milling these things, which is why my suspicion is that CPC is doing a lot of this um, as an investment into Aptera. Like Aptera is not paying, my guess, this is total speculation. Aptera is not paying CPC money. CPC is doing this on their own in return for an investment in Aptera. So CPC is basically putting sweat equity into it. That's my guess, because this is extremely expensive, and either Aptera is getting a major discount from CPC or CPC is doing it as kind of a sweat equity partnership.
And I do think it's worth noting because everyone's seen a lot of other electric vehicle startups and they kind of see their path to production. And you know, we've made amazing progress towards production and now producing production tools, but these are production tools.
Right. They're not soft tools. They're not.
These aren't pre-production tools, validation tools. Like these tools that you see here will produce the body sides for your Aptera. There's no other step. There's no other, you know, next gate.
Okay, so that's a really important point, is that they are making production parts from these dies, and these parts have never been validated in the physical realm. They've been validated in silico, in simulation, but there has never been a part pressed out of these dies yet. The dies have never been made. They're just now getting made. And they're going to press production parts out of these. So they have to be very, very sure that their design and their measurements are what they want. Now, I think they can make some modifications to the die. They can make parts of it thicker, probably by CNCing the dies more to give more internal volume so that the pieces are thicker. But I don't think you can add metal to it and make the parts thinner. So I think there is some adjustment they can make, but not much. And hopefully the simulation in silico is good, and the production parts that come out of these are going to be perfectly fine. And when they validate them, they're going to validate as expected. I think they are the physical pieces, and CPC has been doing this for a long time, and they know the material characteristics of the CFSMC and the strength and the rigidity and all that stuff. So I believe that the simulations are going to be very, very good, but you know, it is a bit of a gamble to spend this much on the dies to do that. But I think this is what CPC does, because whenever they're making it, they have to make these dies. And I don't think that you can make, I don't think anyone's like iterating these dies over and over again. So this is kind of the way that they run it.
These tools will be commissioned in the coming months, and they will produce the body sides for the Apteras that you will receive, you know, hopefully very soon.
Now this is the male part of
Yep.
the mold. So every mold, again, has two parts, the male and the female, or I don't know how they're used and described in tool lingo, but you see that there's a final degree of polishing that's happening right there. And again, you can also see the cross-hatching where the adhesive goes, and different alignment features in the mold, and the die. But this is, and you see actually the conjugate part for the, I think this is a windshield frame. I don't know what that other part is on the bottom. That's a side, I think that's a side reinforcement on the bottom. But there's, most of it's done by machine, but in the end, there's still craftspeople that go through and just fine tune everything. And you see the tools and things that they have at their disposal. Very, I mean, neatly organized for a small facility, and very efficient with the amount of product that they put out of that facility too.
So this is the inner side of the body side.
Correct.
So this is actually where the part ends up. So the last mold that you saw is what comes down onto this mold you see here, and then when it lifts off, the part is still sitting on this mold that you see here.
So I guess the convex part is on the bottom and the concave part's on the top, which I guess makes sense. It's probably easier to pull the part off of a convex side than to pull it out of a concave side.
Holes, the bigger holes are actually push pins.
Right
so
here.
pins actually push up and release the part from the mold. And the little cross hatching that you see, you'll then turn the part over, and that's where the adhesive will go to bond the body side to the tub and other parts of the vehicle.
If you look at the very left, kind of midway on the edge, you see like the same kind of car posters and tool posters that you'd see in the U.S. You know, they also have in Italy. Obviously, they love cars very much there.
Yeah, that region of Italy is quite fascinating with the history of all the supercars that have been built there, and just amazing engineering talent. It's cool to see a lot of guys with great heritage in engineering of some amazing cars that you've seen over the years, but then just go goo goo gaga over Aptera.
They
and,
flip
you
their
know,
lid over it. Yeah, they love it.
The ultimate in aerodynamic efficiency and solar powered. So we were complimented very well over there, I think. Our solar team has made amazing progress behind us here. Really, you know, we had the first production validation with producing kind of 10 panels a day at our other shop, and now we're kind of streamlining our operations here and investigating really the production materials that will take to production. And since you last saw panels being made, we've actually increased the durability of the panels. There's quite a bit more hardness, so the surface finish is a lot nicer, a lot more luster. It has more scratch resistance now, which is great, and it's less reflective. We're also working with materials groups on some coatings that can have some real impact to our solar production, which we think is really cool.
It's also more manufacturable. We don't have struggle with the air bubbles and other artifacts that you see in the manufacturing process. So those are basically non-existent in the new material. So.
Yeah, we had a lot of you know, early production issues and some delamination, and you see the air bubbles over time. And these new panels just you know, they're perfect every time. Every time we see one, I'm just giddy over how cool they look.
Okay, so the backstory on these panels is Aptera's been working on trying all kinds of different lamination techniques to get this to work well, to make it durable and last a long time in the sun, and you know, not scratch up and have good solar transmittance. They had a technique that they were the panels they put on gamma for fully charged, but that technique ended up with a very light panel because they want a very light panel, but was difficult to manufacture, and the success rate of manufacturing wasn't that high. So they switched to a different method that's a little bit heavier, but is a lot more reproducible in the production, and gives them much better and repeatable results. So that's what they're going with. So I think the IP for the solar encapsulation is probably one of the things that is going to be a good for them.
Sorry.
So yesterday we had an interesting visit to our partner who's helping us design and validate our motor inverter. So the Aptera, the Launch Edition, has 3 motors, and each motor requires its own inverter. And because the vehicle is so efficient, we actually have some options that most manufacturers don't have. So as a recovering electrical engineer, and all you electrical engineers out there, you are likely aware of silicon carbide. It's a very low loss power device that's all the rage today in electric vehicles.
Okay, so at fully charged, they said their inverters were silicon carbide inverters, and we had a video about that, talking about how the advantage of silicon carbide is that it's much more efficient than silicon IGBT inverters, but they are more expensive, and Steve is talking about that here.
Vehicles. There's a couple problems with silicon carbide. The first one is cost. It costs about 10 times greater per watt for automotive grade components than, let's say, IGBTs or regular low RDS(on) MOSFETs. The second thing is availability. Every automotive manufacturer wants them because they're trying to get every bit of efficiency out of their inverters. Why? Well, the current losses are proportional to current squared. Now, when you have only one motor and only one inverter, and you have a 4 or 5 or 6,000 pound electric vehicle, the current is it's bonkers compared to the Aptera. So they need every bit of advantage they can get.
So what he's talking about is current squared. That's the same reason that like Lucid went with a higher voltage architecture, because power is equal to current times voltage. So if you have more voltage, you need less current to get the same amount of power. And having a lot of current gives you a lot of resistance losses, and in this case, it also gives you more inverter losses. So he's saying that because Aptera is more efficient, you don't need to push as much power through the motors to make it move and to accelerate it. So it requires less current. And so when you have less current, because the losses are current squared, less current dramatically decreases the amount of losses. So looks like they're playing with using regular silicon IGBT inverters rather than silicon carbide MOSFETs, because maybe the efficiency differences aren't that great. Um, and so I kind of looked into that, and let's see here. So this is a paper where they looked at the differences between um, silicon carbide and silicon IGBT. And if you look here, see, this is the IGBT, and here's the various different generations of silicon carbide. You see that the inverter losses are significant. I mean, they're like triple, double to triple here, and double to triple here. However, if you look at this, so this is IM means induction motors, and this is internal permanent magnet symmetric synchronous motors. So I'm not sure if Elafe is an induction motor or a permanent magnet synchronous motor. I think it is a synchronous motor because um, in real motors, they do better with permanent magnets because you have high torque density. So if that's the case, you can see that the permanent magnet motors, the inverter losses are not that great between the differences aren't tremendous between the IGBT and the silicon carbide. So maybe that's what Steve is talking about, that the differences aren't that big. And then if the cost is a lot better, then maybe they'll go with IGBT and take the small percentage hit on the inverter losses and go with that.
We learned yesterday, seeing our inverter and the motor on the dyno with our, that's actually a prototype Elafe, that's our new design that's on the dyno stand there. What we learned is that we're at a regime where it's not going to make much difference if we actually decide to use a lower cost IGBT as opposed to the silicon carbide that's in here now. So we have that option, and we're looking at that option because we want to do everything we can to make the vehicle cost competitive. We want it to be efficient, and it is going to be very efficient. But if we can take little bits out where maybe the payback is not that great, and then lower the cost of the vehicle, we're certainly going to look at that. So
All right, so they're definitely looking at cost, and I think they understand that because of cost pressures, they can't increase the price of the Aptera um, to a point where it becomes not marketable. And so I think they're thinking, if this results in like a 2 to 5% efficiency hit, but they can save 50% on the price, that may be a trade-off that they're willing to take. So that's looking at that, and this goes to show you that the production design, the shape, that's set in stone. Like CPC is making those molds, the shape of the body panels and stuff, that's set in stone. But things like the inverter, and some of the other things, and especially a lot of the UI and UX, that is still in flux, and that's still stuff that they're working on. So I think they're trying to decide between silicon carbide and the IGBT. Now, the flip side is silicon carbide, because it's more efficient, generates less heat. So there's less cooling that you need to do. So you can save some money on the cooling costs and the thermal engineering of the inverters, though you pay more for the silicon carbide. The IGBT, you pay less for the inverter, but you might have to pay, have a more expensive thermal management system to deal with that. So there's a lot of trade-offs, and that's what engineering is all about. And that's what they're looking into right now.
I think that's actually an exciting part of news, is that the vehicle and the requirements are so small that the gains traditionally seen from silicon carbide are just not that big for Aptera. So maybe we can use cheaper devices.
Yeah, in a lot of ways we see that happen, right? Same thing with the DC fast charge. We charge 4 to 5 times quicker than other EVs out there. So we can have components that are a lot smaller, a lot cheaper.
And what Chris means by that is 4 to 5 times quicker on a per mile basis, not on an actual like amount of energy that's being charged, like kilowatt hours. But for the same amount of kilowatt hours, you're going to go farther miles. So you charge faster on a per mile basis because of the efficiency.
In the end, make the Aptera just that much more better. So drivetrain components, we only have 50 kilowatts a wheel, but you look at some other drivetrains for bigger electric vehicles out there, and they're monsters. So,
but if you've seen the CAD that we have of our design intent inverter, this is it. I think the top is not on it, but this is our inverter driving our motor on the dyno. So pretty cool to see.
Very, very cool. Big milestone. And we just got back from Italy, and we were hosted by CPC and got to bring in all our European kind of suppliers there. And we got to show them the vision we have for Aptera and how we're pushing towards production and all the help that CPC is giving us. I think it was great to kind of show them how CPC really enables our path to production. We don't have to figure out how to make these body structures in high volume. We don't have to figure out how to, assemble them and get them well toleranced and, hang the doors. And, there's a lot of issues that I've seen other vehicles.
Yeah, so I think the CPC partnership has been huge for them. They've gotten in with them, and CPC has a lot of experience making the parts and putting them together and doing the body panels. And then they've introduced Aptera to a lot of their supplier partners in the area. And so CPC has been kind of a gateway introduction to them. And it looks like they've been talking to a lot of investors. And I'm going to skip ahead a little bit. So this is probably one of the most important things that they talked about in this webinar is that they submitted the ATVM loan in the last week of April. And I talked about this in a video a little while back, talking about this might be Aptera's best chance to get into production. Capital markets are hard. They've been talking to, these large investors for over a year or two, and so far nothing has materialized. But this ATVM loan, they have like $8 billion funded. They have more money than they have applicants for. So I think the chances are pretty good that Aptera gets it. And this it would be a really good thing. There'd be no shareholder dilution, and the U.S. government is good for it. So they submitted this, and let's hear them talk about it.
Our ATVM loan application, 214 pages of fun. Dwayne Gibson, a great help in getting this done, but our team too, Blake and the rest of the team, Sarah and Pablo, all contributed to make this application great. And it's been a long time coming. It's been since we started working on it last year. So. The DOE has a lot of information requests, and we have to have kind of a fully flushed application. And there was kind of a lot of things in limbo before we pinned the Delta design. So how we were going to manage the supply chain, how Italy was going to fit into that, how much we were going to do in California versus overseas. And obviously the Department of Energy wants to fund production and technologies here in the U.S. So we really had to have kind of a final plan to get the vehicle to production and all the pieces and parts that entail. And we were able to do that over the last few months and get this application together. And it's a very detailed plan. It's got a lot of numbers and a lot of charts and a lot of great information. And it's off to the Department of Energy, and they are reviewing it now. And the next gates are they kind of do an initial review, and they give us feedback on what it will take to make it a perfect application. And then once we kind of go through the feedback loop with them, then we'll finally get to a point where we can fully submit the application, and then they'll review it and say, okay, you're substantively complete,
Right.
substantially complete. And when it's substantially complete, that means that anything that we buy here can actually work against that loan application. So
Yeah, there's still some caution. I mean, we have to go through a formal due diligence and that whole approval process, but it'll be a very big milestone when we get that substantially complete.
Well, the cool thing is, I think people ask, okay, it's great that you have this application, but when can you start spending money? When can you start to execute the plan? And ostensibly, it's when it's substantively complete. We can start to execute our plan and actually utilize a lot of that loan. That doesn't mean that it's granted, though. You have to actually get it granted, and that may take several months. But once it's granted, then you're just waiting on the funding for that to happen. So.
Okay, so this part is a little bit unclear to me because it sounds like what they did is they did a preliminary application. They're gonna get a review from the DOE. The DOE will tell them what more they need. Then they'll resubmit a revision of the application with the more information that the DOE needs, and then there'll be a substantially complete. But then I don't, they're kind of sounding like when you say that they're getting the money. I don't think that's how it works. Um, you know, I'm familiar with government grants for research, and those are competitive grants. You submit the thing, it undergoes review, and then they fund like the top 10% of the applications, and those people get money. The other 90% do not get the money. Um, so I think that the funding for the ATVM loans is quite good. So they're probably going to fund a large percent of the applications, but I don't think they're funding 100% of the applications. So um, I believe that they could probably start spending money in the hopes that they will get it, but I don't think that when it's a substantially complete application that they're guaranteed to get the money. The grant has not been awarded to them, so it may be a little bit optimistic what they're saying about the way that the grant works, or perhaps I don't understand how the ATVM loan works. I'll look into it a little further. I did look into it when I made this, but I'm pretty sure that the way it works is that it has to undergo a review and they have to award the grant before you get the money. You can't, once the application is complete, does not necessarily mean that you're getting the money.
Very cool effort by the team and an awesome milestone. And it alludes to, when we can start using that loan as we're using the CEC grant right now, which is great to have kind of the first approvals for equipment that you see on the floor here. And, I would, I would love to be independently wealthy and be able to fund it myself, but everything takes money to get this vehicle into production, and all this pretty equipment costs money. And the California Energy Commission has stepped up and is helping, and we are hopeful that the DOE process will go swimmingly. We've still been working a lot of other angles to fund our path to production, and the accelerator program has gone amazingly. I'm just so humbled to every day kind of log in and see this number go up. People buying their place in line for the first 2,000 slots. I think it was a really cool way to give people access to these early vehicles and also fund a lot of the really amazing things that we need to get to production. But this $14 million that we've raised in the past couple months with this accelerator program is the reason why we're continuing to progress with CPC. It's the reason why we've kicked off a lot of other vendors,
Right.
In the battery system, in the solar production, braking, our VCU controller, interior parts, all those things have been enabled.
So in anticipation of not only the CEC grant, but as we're monitoring the inflow from this, we asked the team to come back with specific chunks of money that they can spend. And so there's a very large spend that was approved last week for virtually all of the different engineering zones to move things to the very next level in terms of design release. So things are happening, all funded by this, and it's incredibly helpful for the goal.
We think that this program will progress, and we're almost halfway there. So it will be really cool to see the second half of this program and how hopefully aggressive it will get to earn those top spots. Everybody wants to get the first Aptera off the line, and certainly the first 2,000 will be extremely valuable for a lifetime. But we're waiting for Gamma to come back. You saw in that picture in Italy, we have Gamma over there. It's going to stay for an event in Modena on the 10th through like the 14th, but then it's coming back to the U.S. It's gone.
Okay, so just a quick comment. Everyone I've talked to at Aptera has mentioned multiple times how the accelerator program has been extremely helpful, and they have been using the funds from the accelerator program not only for the burn rate, but also for tooling and engineering costs, and to buy like production line stuff. So it is being used at least partially for that, and that's people have mentioned multiple times how helpful the accelerator program has been. So those of you guys that have been contributing and investing in the accelerator program, yeah, it has been extremely helpful for them, and everyone at Aptera has mentioned that kind of off the record.
On its world tour.
Can we talk about that event at all?
Yeah.
The Motor Valley Fest, I think it's called.
Oh yeah, the Motor Valley Fest. It's
Okay, so I looked this up, Motor Valley Fest. It's May 11th through May 14th. It's in the city of Modena. They've been doing this since 2019, and this is the fifth time they're doing it. It's going to mark several anniversaries. It is the 125th anniversary of Enzo Ferrari's birth, 70th anniversary of the International Autodrome, and 30th anniversary of Lamborghini's death, and the 60th anniversary of Lamborghini's foundation. So it's a pretty big event in Modena, and I guess Gamma is going to stick around there, sit next to the Ferraris and Lamborghinis and other things, and a bunch of people that are into cars are going to get to see it. So hopefully a little bit more exposure, and this is a kind of a big event. So here's kind of a picture of the event from last year. I believe they stream some of this on YouTube, so we may be able to see some of it, some of this event. So Motor Valley Fest 2023, that's what you guys should look for if you want to keep track of it. It starts May 11th and goes to May 14th.
If you're in Modena, Italy, and you want to see Gamma, it will be there. It's a great event for that region, and all of our European suppliers are mostly in that region, so it will be great for Gamma to be seen by a lot of those people, and be alongside some really cool supercar brands that you know and probably love.
And lots of good food.
And lots of good cured meats and Lambrusco. But when we get it back to California, Sarah and her great team will have some amazing events for you to come and see and experience Gamma, and hopefully get more people into the accelerator program. So most of those events will probably happen in Southern California. Hopefully a couple events here at the facility, so you can come and see all the amazing progress we've made here. And meet some of the Aptera people. But that's the plan, is to get Gamma back here, and then start to have some events so people can see, the near production Gamma. There are a lot of things that have happened to Gamma, but when you look at Gamma, it ostensibly looks like a production vehicle. So,
if works out with my schedule, I'll definitely try to get down to San Diego for some of those events, and report for some of you guys that are not in Southern California and can't make it.
Economics and being able to sit in it, I think it was really cool, and a compliment that we took it to fully charged, and we had over 2,000 people sit in the vehicle. There was a line of 2.5 hours. People waited at that show just to sit in the Aptera for 5 seconds, and we got overwhelmingly positive feedback. So, having Gamma back will be a big treat for us internally, and hopefully for anyone that can make it to come see Gamma. And we're still continuing conversations outside of the accelerator program with big investors around the world.
Yeah, we've got institutional investors that we've met with in Europe and in the GCC, and that we're going back to again.
Okay, so I was like, what the heck's the GCC? And I believe what they mean when they say GCC is this: the Gulf Cooperation Council. This is a group of 6 countries, Bahrain, Kuwait, Oman, Qatar, Saudi Arabia, and UAE. And they form like a tight economic, political, and military coordination block. And so they kind of work together. And I believe that's what they're meaning when they say the GCC. It makes the most sense. But I wasn't really sure what they meant when they said GCC.
Later this month. And so those have been happening in addition to the crowdfunding, in addition to the accelerator, because that's the level of capital that we're looking at, institutional investors. And the good news is there's lots of interest in Europe and in the GCC in this space. So we're very happy with the progress that we're making.
Yeah, big institutional investors and sovereign investors in parts of Asia, the GCC and Europe. All those people are investing in technology. Unfortunately, the markets have been rather tumultuous in North America, and we were pushing to raise a lot of this funding last year, but the capital markets were pretty much frozen, into the summer and obviously through the end of the year, and now even even as we speak, you look at some of the news, and it's fear mongering, and right. A lot of
doom
peddling.
Porn.
Doom porn on the internet is a real thing, and you can bury yourself in negative videos. But we continue to raise money. People continue to find Aptera's story, and they support the mission of solar mobility with their dollars, with their reservations for the vehicles, with investment. And it's amazing to see that our story continues, even with these tumultuous times, to be a great one. I mean, $14 million in the last couple months. when you look at the market and some pretty interesting and negative times in terms of news. But I think we're a very positive story. We continue to push to production, and the things that this vehicle will do for the world are compelling. Solar mobility is compelling. It's a mission worth fighting for, and we're so happy that everyone has joined in that mission, making the world a more efficient place, making the world a better place in general. We have a great preview here of the Aptera off-road package. This is just some styling by Jason Hill.
Okay, so I'm definitely gonna have to do a dive into this thing. So this is the preliminary design of the off-road Aptera. And obviously, you can see that there's a lot more ground clearance in it. I don't know how big of a difference it will make in the aerodynamics and the efficiency of the vehicle, but you can tell there's clearly more ground clearance in the thing. Okay, so they talked about looking at big investors, and I think what's happening is they talk to a lot of investors. People are very interested in it, but no one has written them a check yet, and that's the problem. The problem is that no big investor has written them a check yet, and I don't really know what the holdup is. I believe I've talked to Chris, and they do have a lot of interest. Like, people are very interested in it. It's very exciting, and they say that they're interested. I don't know if like the they get initially interested and then they talk to their advisors some more and then they get talked out of it, or what happens. But as far as we know, based on their SEC filings, there has not been a big investor that has actually written them a check yet, and that's kind of what we need. And it's just a numbers game. I think that eventually, if you get like 100 people that are interested, one out of the 100 is gonna, a certain percentage is gonna write the check. And they're just, I think Steve and Chris are just working hard, talking to all these people, and eventually someone's going to write them a check is the thing. However, like I said, I think the best chance of getting money is this ATVM loan, because they are so highly funded. They have more funding than they have applications at this point, which makes the probability pretty good. Um, Okay, so I'm gonna go over the Q&A portion of this at a different video because this video has already gone a little long. Thanks for watching, guys. Any comments below? What were your favorite parts? Like, what were the parts that you didn't understand or were the most excited about during this webinar? Let us know in the comments below. Thanks a lot, guys, and have a great day.